So in this section, I would like to explain about the chapter 3, which is basing software development on reusable technology. It is our fourth chapter, I guess. So even though it is the chapter 3, but however it's our fourth week, right? So okay, I will explain about the basing software development on the reusable technology. Why we use this? Actually, software engineers should avoid redeveloping software that already developed because it will require a lot of cost and time, as well as our resources such as the programmer's time, the programmer's work will be overload, and etc. Therefore, we should avoid redeveloping software. Instead, we can just reuse what we've done before, or just reuse some particular library or particular software that can be enhanced later. So there are several types of the reuse itself. The first is reuse of expertise. So we use the expertise knowledge. We can do this reuse of expertise by looking for expertise documentation. For example, like yes, just the documentation like written in the GitHub or Stack Overflow and etc. Or as well, we can also hire a specific consultant. Hire a consultant, which also can be done. Next is the reuse of standard design and algorithm. Like we are using particular standard or algorithm such as the design pattern, etc. And then reuse of libraries, classes, and procedures. Yeah, just like when you are using Python, then you can just use scikit-learn or keras or anything. And then third, reuse powerful commands built into language and operating system. We also use the powerful commands that already built in the language or in the operating system, as well as use the frameworks. For example, like in the first meeting, I have asked you to do a review of some noticeable framework. And then the last is reuse of complete application. You can also do this one. For example, like when you had a client in the past, he asked you to create a particular software, and then come this new client that asks similar software, then you can just reskin it maybe. So it is also possible. So that's how we reuse the software. It's not only about how we reuse our software, but also reusing the expertise, reusing the design, reusing this algorithm, reuse the frameworks, reuse the libraries, and etc. Of course, there are some challenge, there are some problem to overcome. So for example, sometimes we think that why we have to take the extra time to develop something that maybe will be beneficial for others instead of us right now. For example, like we build something and we are not sure whether this project will be a long-term project or instead just a single time project. That means we don't really know that if we build the reusability of the project, it will beneficial for us. So this is the first question. Of course, we have this question. And then the second, the management only reward the effort of the people who create the feasible final products. That means if, let's say, we have an effort like this one, okay, this is our work, this is our code. So this is the real product that will appear to the eyes of the management. Oh, this is good. Okay, this is the work, but this is the code that you prepare for the reusability. This is like an unnoticeable work, but this is important. So you have to know that this problem will overcome. I mean, like, sorry, this problem will appear, and yeah, you might be thinking about how we maintain this one, and this load can be considered as also an effort in the view of the customer or the management. It's a bit tricky. Third, reusable software is often created in hurry and without enough attention to the quality. Yep, there are a lot of projects that are not really taking into account about the quality. So this is like an ugly code here. So the reusability might be very challenging. So because it is created in hurry, so the time management is important too if you want to create the reusability, if we want to construct the reusability in our software. There are a vicious cycle. A vicious cycle is when the developers tend to develop high quality of reusable components, so there is often little to reuse. So to solve this problem, we have to recognize that the vicious cycle is cost money. The vicious cycle is like yes, we have many constraints, but we have to deliver the high quality as well. So it's like, okay, I can do this, but the time is so limited, or my resource is limited because my programmer is already busy with another project, and etc. So we have to notice that first, this vicious cycle will cost money later in the future. If we don't create the high quality but enough space to develop the reusability itself, it can cost money, not only these ones but also in the future. And then the investment in the reusable code is important, of course, because if you do not invest the time in the reusability, and next when we are going to develop something else that's similar to our current problem, to our current work, then maybe we have to build it from scratch again, and then yeah, it will take a lot of time, effort, and etc., as well as money. So investment in the reusable code is important. Third, attention to the quality of reusable component is essential. So to create a high quality software, you have to maintain the quality of the reusable component itself. So when the reusable component is not really high quality or didn't match with the future requirement, it will lead into what we call reusable component. I mean, like, it's not reusable. It can be used again. Like, okay, it can be used again in the future. So it's just wasted money, time, and etc. So make sure that the reusable component can be reused in the future. So it has to be in the good quality. And then develop reusable component can often simplify the design. Developing reusable component often can simplify the design. Yes, of course, because sometimes the more general the design, it will be better for the future. So we can just like adding something else or change something else, and etc. Instead of deleting some functional, it will be better. It will be easier to just adding some functional in the future, right? So when we are going to delete something that we have created, maybe it will lead to an error, defect, and etc. But if we create something that is more general, more simply, then in the future we just need to add the additional feature, right? Framework is another example of the reusable subsystem. Framework is reusable because it implements generic solution to a generalized problem. That's what I previously mentioned to you. So the good reusable system is something that is more general. So in the future, instead of I have to delete this one, I can still use this whole system and I add a new feature. So this is very good. So that's how framework work. The framework work by generalizing the problem. I mean, like, it gives generalized solution. It gives generic solution. Framework also promote to reuse, of course. It's like what I said before, as well as we can use the service using the API and etc. We can certainly add additional features that are missing using the slot, like I said before. Okay, let's say I have this framework, and then this framework is very good, but I need some additional features, so I will just add these features here. So it's better. So framework provide the generic solution, and then because it is incomplete, so we can add additional features here in the slot. Now, what is object-oriented framework? In the object-oriented paradigm, framework is composed of library and classes, right? So it's just like the object-oriented system. Framework consists of a lot of library as well as classes. So some of classes will normally be abstract and often many of interface and etc. It's also used a lot of methods, public methods and etc. So basically, framework is utilizing the object-oriented paradigm, because by using that specific framework, we can do it in our team. We can divide our work to our teams and etc. Like the object-oriented system, like the object-oriented programming concept itself, because there are a lot of ways and etc. that we can update later. We can have a specification. I mean, like we can have an inheritance from specific class, from the abstract class. We can inherit something. You can do the interface thing and etc. from the framework. So that's why the framework implement object-oriented paradigm. There are a lot of framework, of course, like the payroll management, like the buyer, universal registration, e-commerce website. You already do this, say some research or just like okay, you already learned this one when in the first meeting, I guess you already create the resume. Okay, this is the types of the framework. So there are two types of the framework: the horizontal one and the vertical one. What is the differences between the horizontal and the vertical? The horizontal framework is framework that is more generalized, and then this one is more specific. So because the first one, the horizontal one, is more generalized, so it can be adapted by a lot of a lot of application, because it is more general. So we can, okay, I will add this feature here. So I want to create another, this A, maybe this is a B application. I can add this application and then give it additional feature here, and I will take this one and I will just grab this feature and build it into mine and etc. So this is the horizontal framework. Horizontal framework is framework that provide general application facilities of a large number of application. So it's like Bootstrap. Bootstrap can be used in any website, right? So I mean, like there are a lot of websites that use that framework. So the Bootstrap itself can be can be implemented into many type of the object, not only an e-commerce, but also maybe like an e-learning or health system maybe, or just your work, your final project and etc. So it's more general. It is a generic version of the system, so it can be implemented, it can be used by a lot of application. In the other side, we have the vertical framework. The vertical framework is a framework that designed specifically for specific purposes. For example, the e-learning framework. There are e-learning called Moodle, which is special for the e-learning, and this e-learning already built a lot of features here. So the feature is nearly complete. It's nearly complete. So there are not so many space for us to add the additional features. Like okay, we can just like tweak something here, tweak and do like just change this one little bit and etc. But we can't like add more features, more detailed features. We can't do this because it's already nearly complete. Okay, it's not really complete, but we can change something, but of course not so much. So the example is model, we can use that because it's put specifically to the e-learning itself, so we can like just add something, add plugin, but this so little, then not we can't change so many features in the model itself. Next, the client-server architecture. The client-server architecture, I think you already know this one. Like when you are playing the game, that's just the client-server and etc. Okay, so what is server? Server is a program that provides a service for other programs that connect it using communication channel. Server is a program that is give the service, and then the client is a program that access the server to get the service. This is the client. Okay, the next is the sequence of activities in a client-server system. The first thing to do is server will start running. So this is the server, it start running. And then the server will wait for the client. Here we go with the client here. We got a lot of client here. And then the client will attempt to connect to the server. Okay, I want to connect. Okay, fine. Let's create a communication channel. So after it creates a communication channel, it will send the message from the client to the server, and it will give the reply, and at the end of the communication, it will end the communication. This is the sequence diagram of the communication between the server as well as the client, but in this case it is to client. So like the first one, the server will listen for the connection, and then the client one trying to connect, client one trying to send message, and then in this time client 2 trying to connect. The server will reply to the client 1, the client trying to send message while the client 1 trying to disconnect. Okay, and then this one is disconnecting from the server side. So the disconnect can be the request from the client as well as from the server disconnect the client. And then this one is when the server stop listening. Of course, there is an alternative to the client-server architecture, which we call single program for single computer. That means there is no communication needed. No communication needed because it's the computation as well as the data processing will be done in the same place, in the same computers. Why it is more advantage? Why there is more advantage in the client-server system? Because the first thing, in the client-server system, the work can be distributed among the different machines, which means we can do the work in parallel. As well, the data can be kept centrally. I mean, it will keep or maintain the integrity of the data. Like we have a data side here in the server side, and then in the client side we just do the computation, do something here, but the data, because it is centrally in the server, so it will maintain the integrity. This is the example of client server system: World Wide Web, email, NVS, transaction processing system, database system, communication system, as well as remote display system. This is just another example of the activity diagram of the server. Just like what I previously said to you, the first one is the server initialize himself, and then this is the state of listening the message. So this is the server will wait and then start listening, and then wait for the connection, accept connection, and then stop listening, and then terminate the process. This one is for the client side, initialize, and then try to connect to the server, and then interact with the user, sending message as necessary, or just respond to the events like respond message, handle connection, and then just terminate. This is the example of threads in client-server system. Next is the thin versus fat client system. Actually, there are two kind of client concept. The first one is the thin client, which means that the computation in the client side will be light. This is the thin client because it is light computation in the client side, but the second picture represent the fat client system because there are a heavy computation in the client side. Of course, for the first picture, first image about the thin client, the client is made as small as possible, and the most of the work will be done in the server side. So the processing the data is in the server side. In the other side, the fat client have heavy computation in the client side, and then the data and etc. is here. So the light computation will be done in the server, like just okay, request for service vault, and then the result of the service. So it's just small computation in the server side. The advantage of the fat client, of course, it can handle more client because the computation is light, so it can handle a lot of client. Next is the communication protocol. It is the protocol that used between server and client to communicate each other. Actually, there are several technologies that needed to build the client-server system. The first one is the Internet Protocol, and then the TCP, and also a host itself has an IP address as well as a host name. Luckily, in the Java, we have the java.net package. Luckily, in the Java, we have the java.net package, which allow the server as well as the client communicate through TCP/IP. Before the connection is established, the server must listening to the one of the ports. So we create the port here, server socket as well as the client socket, and then sorry, not the port. We create the server socket object and the client socket object, and then this one in the server socket it it receive the argument of the port, as well as in the server socket it accept to create the client socket. This is the exchanges information in the Java. It uses the stream. Input stream is to receive the message, while output stream is to send the message. Of course, there are several risks using reusable technology, such as poor reusable component, which I mentioned before, compatibility that is not maintained, investment. This is the example of client-server app that you can try. This is the client side. This is another risk, like the competition and divergence, security as well as the attractive. Okay, so the task is you have to create the client-server app. The task is you have to create client server app that calculate the body mass index in 2 weeks. Thank you.